Myself, Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology. So today, the topic which we are going to discuss from the subject of series Aerospace Propulsion 1 is frame of reference. So in previous classes, we have gone through the basic principles behind the aerospace propulsion. That is about the space, what is gravitational force, what are the Kepler's laws, how the planets are revolving around the sun, and all this. So, in order to describe the motion of any body, the frame of reference is very, very important. Okay, so that is the topic today. Let us start the topic today. So, if you go to the overview of today's presentation, topics which we are going to discuss are inertial frame of reference, non-inertial frame of reference. Okay, so generally reference frame is nothing but a point with which we are measuring the properties of a body. That means how the velocity, acceleration, everything will be calculated with respect to a certain point. That is nothing but called as a reference. Okay, here there are two types of reference systems, that is inertial frame of reference and non-inertial frame of reference. So coming to the frame of reference. In the frame of reference, suppose why frame of reference is required. Suppose if I take an object like this, okay, I say the object is moving with some velocity v, and that v is equal to 5 meters per second. Okay, so I have taken some object 1 and it is moving with some velocity v, and that is equal to 5 meters per second. Okay, so next there are two bodies. Okay, there are another two bodies. One is body 2 and one is body 3. Okay, so now body 2 is at rest and body 3 is moving with some velocity v3 is equal to 5 meter per second. Okay, both are on the ground. So now if I want to calculate the velocity of body 3, that is 5 meter per second with respect to the stationary system, that is ground, and with respect to 2 is stationary, right? 2 is just standing, okay, in one place. Then the velocity of body 3 with respect to 2 is also 5 meters per second. This is case 1. Now I am going to take the another case. Okay, I am going to take the another case 2. Okay, in this case 2, what happening is this body 2 is also moving with some velocity 2 meters per second. This body 2 is moving with a velocity 2 meters per second and body 3 is moving with the same velocity 5 meters per second. And now I am assuming a third person, some other person standing on the ground and watching these two bodies, body 2 and body 3, both are moving with some velocities 2 meters per second and 5 meters per second, right? So if you say here 2 meters per second, this velocity is with respect to this body, this stationary person, and here 5 meters per second velocity of body 3 is with respect to this stationary person. Okay, now if I want to calculate the velocity of this body 3 with respect to 2, then what is the velocity? So velocity of body 3 with respect to 2 is 5 minus 3, that is equal to 5 minus 2, that is equal to 3 meters per second. Isn't it or not? So the third body velocity with respect to second body is only 3 meters per second, but the same third body velocity with respect to the stationary person is 5 meters per second. So what is the difference? So in the first scenario, if I take the velocity with respect to this person, it is 5 meters per second. If I take with respect to 2, it is 3 meters per second. That means the body is same, the velocity, the body does not, the motion of the body does not change in any manner, but the velocities are changing if I am considering the references. That means here this person is one type of reference, and the second body which is moving is also another type of reference. So if I take the reference system with which I am calculating the properties, that is velocity of the body, then the values are changing here. So that's why this frame of reference is very important to analyze the motion of your bodies. Here the motion of body is same, but the values are changing if I am changing the reference with which the parameter is calculating. So that is why this frame of reference is a very important topic to understand the motion of bodies in space. Okay, why it is important in space? So if I consider a motion of a body on the earth we consider earth is a stationary, and we can calculate the parameters like velocity, acceleration, everything. But if you go to the space, what happens is space, suppose if we consider sun like this, so planets are revolving around the sun, right? So I am taking earth. Earth is not just revolving around the sun, it is also rotating about its own axis. Earth is rotating about its own axis. And if I take moon here, moon is also rotating around the earth. Moon is rotating around the earth, and earth is moving around, like moving its in its own orbit. That means here the velocities, if I based upon the reference, based upon the frame of reference, the parameters or the path followed by the object is changing. Suppose if I take earth, if I take one object which is moving on the earth from to a distance of 1 kilometer in a linear distance, but if I see the same from space, it will make a small curve. It is not actually a linear line, it is a straight line. Okay, suppose like that. So frame of reference is very important to understand the motion of bodies in space. So coming to the frame of reference, there are two types of frame of reference. That is, we have already gone through that: inertial frame of reference and non-inertial frame of reference. In that, inertial frame of reference. So what is inertial frame of reference? The frame of reference used for defining the position of a body is either stationary or moving with constant velocity along a straight line is called inertial frame of reference. So if I take any reference system, if that reference system is either stationary, that means it is not moving with any velocity, velocity is 0, or else the stationary system can move with constant velocities. Here you can see the first case, that is stationary coordinate system. So it is comes under inertial frame of reference. Velocity is 0 here. This frame of reference is 0. Here the frame of reference is x, y, z with axis, and this body here a person is standing at origin. The second, the moving with constant velocity. So the same frame of reference, if it is moving with constant velocity, then also we can consider that frame of reference is inertial, comes under inertial frame of reference. Why we consider these two cases as inertial frame of reference? Suppose if this body velocity is changing with respect to time, if this frame of reference velocity is changing with respect to time, then it is not comes under inertial frame of reference. It will be considered as non-inertial frame of reference. So why it is considered as inertial frame of reference in these two cases? Because the velocity, momentum and acceleration of the body do not depend on the frame of reference used. If the velocity of the reference is 0 or else it has constant velocity, then the velocity, momentum and acceleration of the body does not change, the values does not change with respect to the it does not depend on the frame of reference. It is independent. Okay, so that's why we consider these two reference systems comes under inertial frame of reference. Examples. What are the examples comes under inertial frame of reference? A car that is traveling at constant speed provides inertial frame of reference for the passengers inside. So if I take a car, okay, some passenger is sitting in it. So, and the car is moving with some velocity, constant velocity v. Okay, then for the passenger, okay, for that passenger, the car is inertial frame of reference. Car is moving with constant velocity. So the passenger, whatever he do, we can calculate the motion of that person. That is with respect to car, that is inertial frame of reference. So car is an inertial frame of reference. And even we can consider motion on ramp. Motions on ramp. Suppose if I take one motionless ramp, motionless ramp. Okay, if I take some object, it is rolling on it. Okay, this ramp, whatever the object which is with this motionless ramp is, velocity is 0. So it is also considered as inertial frame of reference. I consider the speed of this sphere with respect to the ramp. So this ramp is a inertial frame of reference. So the frame of reference should be either it should be moving with constant velocity, or else it should be at rest. Then that is called the inertial frame of reference. Next is non-inertial frame of reference. Non-inertial frame of reference. So it is simply if the reference frame is either moving with some acceleration, though it is not at rest, or not moving with constant velocity. So not moving with constant velocity means the velocity is changing with respect to time, that is it has some acceleration. If the frame of reference has some acceleration, then that frame of reference is called non-inertial frame of reference. So the example, so reference frame, here you can see earth is here, we can see the earth, and if you consider the earth, this is north pole and this is south pole, and earth is rotating about its own axis with a speed of 0.46 kilometers per second. Suppose I am sitting here in my studio, right, in a chair. With respect to the earth, I am not moving, I am at rest, I am not moving, I am sitting in the chair, right? But if a person who is in the space observes me in a telescope or something, then he can observe that I am moving with a linear velocity of 0.46 kilometers per second around the earth axis. Okay, with respect to earth surface, I am stationary, my velocity is 0. But a person who is in space, not related to the earth, he is in space, he will observe that I am moving with some velocity 0.46 kilometers per second. That is the rotational speed, linear velocity of the earth. Okay, so coming here, earth is actually a non-inertial frame of reference because it is constantly rotating and revolving around the sun. In the previous slide itself, we said if it is moving with constant velocity, then it is inertial frame of reference. But earth is not moving with constant velocity around the sun. Suppose if you take sun here, earth is making an elliptical orbit around the sun. If I take sun here, earth is making an elliptical orbit around the sun. So the earth will make different velocities at different position while moving around the sun. So velocity of the earth is not constant in its orbit. So earth cannot be considered as inertial frame of reference. It is actually non-inertial frame of reference because it is revolving around the sun. So a reference frame attached to a non-inertial frame of reference is also considered as non-inertial frame of reference. So also cannot be taken as inertial frame of reference. Suppose if you take any inertial frame of reference which is attached to the non-inertial frame, that is also considered as non-inertial frame of reference. But what we generally do is we consider earth. Suppose if you do any calculations within the earth surface or in the earth atmosphere, we consider the earth as inertial frame of reference up to some extent. But if you go to the space, then earth is non-inertial frame of reference. If I want to calculate the motion of bodies in the space, if I want to send a rocket to the moon, then I have to consider the earth as non-inertial frame of reference only. So this is about today's topic. So we have discussed inertial frame of reference and non-inertial frame of reference, and we have gone through the examples and differences. Thank you.